Hey guys, welcome to day 20 of 100 Days of Code. Today is really exciting because we're going to be using the knowledge that we've gained about object-oriented programming as well as what we learned about how to use the turtle module to build the famous Snake game. Now, this is probably one of the most famous mobile games there ever was, and it's definitely one of my favorite. And my history with it goes back all the way to my very first mobile phone, the Nokia 3310. I might be showing my age a little bit here, but this was my first ever mobile phone. And I remember loving it so much that I actually had it next to my pillow when I went to sleep. And this was probably one of the first affordable mobile phones, and it was endlessly customizable with different cases and different keys. But the most exciting thing about it was the Snake game. I would compare with my friends and see who got the highest score in Snake, and we would spend days and days playing this game. And compared to the iPhone games of today, of course, this was very, very simple, but nonetheless, it is still super addictive. Over the next 2 days, this is the game that we're going to build. A snake game that has a moving snake which you control using your keyboard, and it can go and get food, and then it grows in length as it eats more food, and you have to make sure that you don't end up getting tangled or hitting the wall, and the goal is to eat as much food as you can while staying alive. There are some people who are truly masters at this game, which I personally am not, but they manage to get their snakes to crazy lengths and start having these strategies for how you can avoid hitting your tail and how you can keep going. So once you've built your snake game, you'll be able to play with it and you'll be able to show off your high scores to the rest of us, but I'm sure you're going to do a lot better than me. It's not that hard to beat me at Snake. As always, when we're thinking about a complex problem, the first step is to break down the problem. And I'm going to break down this problem of building the Snake game into 7 separate steps. And the way we're going to do it is we're going to tackle the first 3 steps on day 1 and the last 4 steps on day 2. So we're going to split up this game into 2 parts and we're going to tackle it over 2 days. The first step is to create a snake body. And we're going to do that by creating 3 squares on the screen, all lined up next to each other. And then we're going to figure out how to move the snake so that it continuously moves forwards, and all we have to do is tell it to change direction. Afterwards, we're going to figure out how to control the snake using keyboard controls. So we're going to be using the up, left, down, and right arrow keys to move our snake across the screen. And that is what we're aiming for by the end of today, day 20. On day 21, we're going to continue and we're going to build out the last 4 steps of the snake game. Then we'll need to start putting some food onto the screen and start to detect collision with the food, so that once the snake hits the food, then a new piece of food gets created randomly on the screen at some sort of random location. And then it's a matter of keeping track of the score and creating a scoreboard. So we're going to learn how to write text in our program so that once the snake hits a piece of food, the score automatically updates. And then next, we're going to figure out when the game should end. So one of the cases when the game should end is when the snake has collided with the wall. And at this point, we should see game over show up on screen, and the snake should no longer move. And then finally, the other reason why our game could end is when the snake has collided with its own tail. So the snake basically can't chase its own tail, and as the snake gets longer, this problem is more likely to occur. And when the head hits any part of the body of the snake, then it's again game over. So these are the 7 steps that it takes to create the snake game. And once you're ready, we're going to get started with step 1 on the next lesson. So I'll see you there. The first challenge is pretty simple. We're just going to create the starting screen. It's going to be a screen that has a height of 600 pixels and a width of 800 pixels. It should be black in terms of the background color, and it should stay on the screen until we click on it. So using what you've learned so far, go ahead and set up the starting code for our project. Alright, so I've created a brand new project, which I've called Pong Game, and I've created a main.py. Now, the first thing I'm going to do is I'm going to import a screen from the turtle module. And then I'm going to create a screen object from this screen class, and then I'm going to set the background color to black. And then, of course, we'll need to set up the screen so that it has a width of 800 and a height of 600. So now if I run this code as it is, you'll see that it flashes up and it disappears. So of course we need that exit on click method as well. As a final finishing touch, this is completely optional, but it helps to identify the program. We can change the screen's title to, say, Pong. And now when I run the code, you can see that this window now says Pong. So we now have our 800 by 600 screen, and we're now ready to head to the next step where we create our paddles. So now that we've created the screen, we're ready to go ahead and create and move a paddle. So the paddle that we're going to create is going to be on the right side. It's going to have a width of 200, a height of 100, and be positioned at 350 pixels on the x-axis and then 0 on the y-axis. So this is the sort of positioning we're looking for. And additionally, we should be able to hit the up and down keys on our keyboard to move the paddle. Each key press should move the paddle up or down by 20 pixels. Have a think about how you might create the code for this and pause the video and complete the challenge. Alright, so to create this paddle, it's going to be created as a turtle. So let's go ahead and create our paddle from the turtle class, and I'm going to set the paddle's shape to a square. In order to stretch it so that it's 20 by 100 pixels, remember that all turtles start off as 20 by 20. So that means in the width, we have to stretch it by 5, and in the length, we leave it as it is in order to make it 100 by 20. So let's go ahead and hit up paddle.shapesize, which is what we've been using so far. And then in terms of the stretch width, we're going to make that 5, and then the stretch length is going to be 1. Now we have to make sure that our paddle has a color of white so that it's actually visible when we run our code. And you can see there it is. There's our paddle. And as always, it gets initialized in the center at the coordinate 0, 0. So in order to move it to the position we want to, we have to get it to go ahead and pen up, and then we can tell it to go to the position that is 350 by 0. So 350 on the x-axis and 0 on the y-axis, like that. Now, the next thing we need to do is figure out how to get it to move up and down. So, of course, we need some sort of way of getting our screen to listen for keystrokes. We're going to call screen.listen, and then we're going to call onKey in order to listen for the up key. And then when that happened, we're going to get the paddle to go up. Now, remember, as always, when you're using a function as a parameter, you don't want to add the parentheses. If you do, it won't work. Now let's create our go up function, and this function is going to take our paddle and move it so that it goes to a new position. The new X position is not going to change. The only one that's going to change is the Y position. So the Y position is going to be the paddle's current Y core, but it's going to go up, so it's going to need to plus, let's say, by 20. Now we can tell the paddle to go to its current paddle.xcore. So we're not changing that, and then to go to the new Y position. Now this go up function is going to be called whenever the up key is detected. And if we copy this and we make a similar version of this function, which is called go down, and we can subtract 20 instead. So now we can copy this line and make it call go down when the down arrow key is detected. So now we've created our paddle, and when I hit up, it goes up. When I hit down, it goes down. And this completes the first part of the challenge. But here's a question. When I hit run, you can see that the paddle first gets created in the center, and then it moves to the location where it needs to go to, which is 350 on the x-axis, 0 on the y-axis. How can we get rid of this animation so that we don't have to look at the paddle move to the position? Have a think about what you've learned in previous lessons and see if you can solve this problem. Alright, so you might remember from previous lessons that there is a tracer method on the screen which controls the animation. And in order to turn off the animation, we can put a 0 in that method. But when we run our code as it is right now, you'll see that there's no animation, there's not even a paddle showing up anymore. Remember that when you turn off the animation, you have to manually update the screen and refresh it every single time. To do that, we'll need some sort of a while loop. And the while loop is going to check for some sort of variable. So let's create a variable called game is on and set it to true. And while the game is on, then we're going to call screen.update. Now, if I run the code again, you'll see that my paddle now goes directly from the center to the position, because the first thing that happens is the animation gets turned off, the paddle then gets created in the background, and then finally it gets to this point where we actually update the screen and show everything that's happened in the background so far. Did you manage to complete this challenge and create the paddle and get it to move up and down using the keystrokes? If not, be sure to review some of these methods in the Turtle documentation and have a play around with the code until you're fully happy with what's going on so far. Now, if you had created the paddle in a separate file as a separate class, don't worry, we're going to do that next. We're going to refactor this code so that it's fully compliant with object-oriented programming. But if you've already done it, then you're just one step ahead. And that is where we're heading to in the next lesson. So far, we've managed to get our starting segments for our snake to appear on screen. And then we managed to get our snake to automatically move forwards and to figure out a way for the tail of the snake to follow where the head is going. Now it's time to tidy up our code a little bit so that all the parts that are related to the snake's behavior and the snake's appearance go into a separate class. So that by the end of the whole project, we should end up with 3 classes: a snake class, a food class, and a scoreboard. And all of these classes will be in separate files managing only one thing. And the goal of the refactoring is so that you could create a separate file, snake.py, import the snake class that you've created in that file, and then once you initialize the snake, it will do everything that we have so far and create our 3-segment snake onto the screen. And then finally, while the game loop is running, we're going to get the snake to continuously move forwards just by calling snake.move. This is what you're aiming for. Have a think about how you can take the existing code that you've got in the main.py and extract all of the snake related functionality into a separate snake class and make your main.py end up looking like this. The program should do the exact same things as before. The only difference is how the code is organized. Have a think about this. You might need to revise some of the things you learned about how to create classes, how to create objects from the previous lessons. But pause the video. I want you to give this a good try before you come back when we'll go through the solution together. All right, so the first thing we need to do is, of course, to create our snake class. And remember that in Python, class names are in Pascal case, so the first letter needs to be capitalized. And then inside this class, I'm going to create my init. Now, the code in here is going to determine what should happen when we initialize a new snake object. So firstly, I'm going to take these starting positions and take it over to our snake.py. Now, I'm actually going to put this in as a constant, so right at the top. And remember that in Python, the constants are named with all caps like this, and also with snake case with underscores separating each of the words. Now we can use these starting positions inside our snake class to create our new snake. So we're going to need to move our segments over as well. So let's create a new attribute that's associated with our snake class called segments. And remember, we're going to need to use self when we're working within a class. After that, we're going to create our snake. So I'm going to create a method called createSnake down here. And this method is going to do everything that we previously had over here, but we're going to move that into this method. Now, there's a couple of things we need to change. Firstly, we changed these starting positions into a constant, so let's make that consistent. Second thing is that we need to import turtle into this file from the turtle module in order to use it to create a new segment. And then finally, in order to refer to our attribute segments, we have to say self.segments and then append this new segment to our snake segments. That's this part done. The next thing we need to do is to get rid of this code and move it inside the snake. So again, I'm going to create another method that's associated with the snake class called move. So when the snake moves, it's going to look to this code to figure out how it should do that. Again, because we're inside our class, it's no longer just segments. It's now self.segments. So let's go ahead and replace it in all the places where we have our red underlines. And now that's pretty much it for our snake class. We can create a new snake object, and each time we do that, it creates a 3-segment snake using the starting positions, which are declared at the top. So if we want the snake to show up on screen, then we're going to have to first import the snake class from the snake file, and then we're going to create a new snake object from that class. And once this line gets triggered, then we're going to be calling createSnake, and our 3-segment snake will show up on screen like this. Now, the next step is while the game is on, the screen is going to update every 0.1 second. So that's essentially what this is doing. It's saying that delay for 0.1 second and then refresh the screen. And every time the screen refreshes, we're going to get the snake to move forwards by 1 step. Now, at the moment, each step is defined here as 20. So again, I want to extract that into a constant up here. So we're going to call it the move distance. And we can set that to 20 and then change this to use the constant here. And the reason why we have all these constants is so that if we wanted to tweak our game, say if we wanted the snake to start at a different position or for it to move further each time, then we don't have to dig through the body of our code. All we have to do is look at the top, look at all the things that we can change, and then change it accordingly. So now coming back to our code here, all we now really have here is just these few lines of code. And everything that is snake related, creating the snake or moving the snake, is now abstracted into its own class. This way, when something goes wrong with our snake, we know who's responsible and which file to dig through to figure out the reason. Now, at this point, if we go ahead and rerun our code, You can see that our program works exactly the same as before. Nothing should have changed and nothing should have broken. Now, because our game isn't yet able to go into the game over sequence, there's no way of stopping the snake other than hitting the stop button. So don't worry if at this stage inside your console you see a lot of red and it says things like keyboard interrupt or traceback errors. All of these are normal. The thing that you're more concerned about is whether if when you run the game, whether if it actually works like it used to. So namely your snake moving across the screen. If it does exactly what it used to and your main.py is now much simpler and all of your snake functionality and behavior and appearance is now inside its own class, then you have successfully achieved the goal of this lesson. Now that we've created both paddles, the next obvious step is to create the ball and get it to move. So this ball is going to be created as a separate ball class, and the ball object that we're going to create from it will have a width of 20, height of 20, and its X and Y position will start out at the center of the screen, so 0, 0. Now, when the screen refreshes, the ball is automatically going to move on the screen and it's going to move up and also to the right. So its X and Y positions will change on every refresh of the screen. So this is going to be a little bit more challenging and will require a little bit of thinking from your part. But I want you to pause the video and give this problem a bit of thought and see how far you can get in trying to get the ball to move to the top right edge of the screen. Pause the video and give that a go. All right, so to start off this time, I'm going to create a ball.py file, and inside this ball.py is where we're going to create our ball object. So firstly, I'm going to import my turtle class, and then I'm going to create my ball class, which is going to inherit from the turtle class, and then I'm going to do all of the usual initialization, and now we're ready to create our ball class. This ball is going to firstly have a white color, and in addition it's going to have a shape that is going to be a circle. Now I know that in the original Pong game the table tennis ball is actually a square, so you can keep it a square if you want to be historically accurate, or you can change it to a circle like I have here to make it look more like a ping pong ball. Now, in addition, we're going to need to get it to pen up so that it doesn't end up drawing across the screen. And now all we need is to initialize our ball from the ball.py. And we're going to do that just below our paddles. So I'm going to create a new ball object from the ball class. And now if I hit run, you'll see our circular ball show up in the center of the screen. The next problem is, how do we get the ball to move towards the top right corner of the screen? So that's going to involve a change in the X coordinate as well as the Y coordinate. In our while loop here, where our screen is updating, we're going to call a method in the ball class, which is going to be called move. And this move method, which we'll define now, is going to be responsible for moving our ball. And the way that it's going to move is it's going to increase on the X and also increase on the Y. Let's create a new X coordinate, which is going to be the current self.xcore plus a arbitrary amount. So let's say increase by 10. And then the new Y is going to be the self.ycore increased by the same arbitrary amount. And then finally, we can get our ball to go to this new X and new Y. So now when we run our code, you can see that our ball immediately goes off the screen to the top right corner. If we want the ball to slow down a little bit, we can do one of two things. Either we can go into the move method and change this 10 here to say a 1. That way, every time our loop runs, our ball will only move 1 pixel. Alternatively, we can pause the loop for a short time during each iteration. Moving the ball a tiny amount does work, but I'm going to go with the second option and import our time module. Then I'm going to get our while loop to sleep for a little bit in between each of the updates. So I normally start off with just a 0.1 second sleep, and you can see now our ball moves at a more reasonable pace and we actually have a chance of catching it with one of the paddles. That's all there is to it. We've now created our new ball class, initialized a ball object, and we've got the ball to move on every refresh of the screen.